So today I'm going to be talking about the abstract factory pattern. This pattern is a creational pattern. It creates families of related objects without specifying their concrete classes. A good example of this is thinking about we have a web app that has two different completely different visual themes. There's one that's like a text-focused theme, and there's one that's an image-focused theme. So each theme has their own navigation bar, window, container, and has like a content area. A really important idea is that we don't want to mix elements of the navigation bar and content area across the different themes. We want to make sure that we don't want to have a text navigation bar with an image content area. The way that we could possibly do this is thinking about having conditionals, looking at if the theme is text, we have to create a text navigation. If it's image, then we have to create an image navigation. If we think about this, we're going to have to do this conditional all over with each different component within the theme itself. Instead of that, we can think about using this pattern instead of having all of those different conditionals based on the theme, based on the component. The core problem that we have with that we're trying to solve is we have coordinated families of objects that you need to be able to swap the entire family at once without touching any of the code that uses those objects. The client, which is the code that navigates the navigation bars, the windows, and the content area, those should be completely ignorant of which concrete classes it's working with. It should just ask the factory for a navigation component and get back something it can call the method display on. Here's a quick pattern overview. The abstract factory is a creational design pattern. The gang of four definition is it provides an interface for creating families of related or dependent objects without specifying the concrete classes. The key phrase here is family of related objects. This isn't about creating a single thing. That would be a different method. That would be the factory method. Abstract factory is about creating an entire whole coordinated set of things and guaranteeing that they'll work well together because they all come from the same factory. It's creational because the primary purpose is controlling which concrete classes get instantiated and doing so in a way that the client never has to worry about. For our demo, here's the structural diagram. At the top, we have the abstract factory. That is the interface that declares one factory method for each of the product types in the family. So here we have create navigation, create window, create content. Below that, we have the concrete factories, one for each product family. Then you have the abstract products, an interface for each product type. And finally, concrete products that implement those interfaces. The client only ever talks to the abstract factory interface and the abstract product interfaces. It never references the text theme class or the image navigation class directly. That's the entire mechanism. We have dependency inversion across a whole product family. The first participant we're going to look at is the display theme generator. That's the abstract factory interface. It declares exactly three factory methods: the create navigation, the create window, and create content. Each one returns an abstract product interface. It's not a concrete class, and this is a contract that both the theme, text theme, and image theme must fulfill. The client code holds a reference type, the display theme generator. It can swap in either factory without touching anything else, and that's the power of the pattern that we have. The next participant that we have is the abstract products. We have the display navigation, display window, display content, and each one just has a very single display method, and that's all the client needs is just a way to tell the component, tell how the component can render itself. Notice the client never calls text navigation or image navigation by name. It just calls the display method on whatever product the factory handed it. The interface segregation principle works perfectly alongside the factory pattern. The text theme that we have is the concrete factory, the first one. It takes three DOM element references in its constructor. It has the nav element, the window element, and the content element, and it passes the right one to each product constructor. When you call the create navigation method on it, you get the text navigation. You call the create window method, you get the text window. You call the create content, it will give you the text content. And also all the text product family has their own specific visual identity, theme, look. And so the next one we have is the image theme. The image theme is the Concrete Factory B. It has the same interface, completely different products. Its navigation bar is purple, the window is wider, its content area renders an image. Here we have the same thing. It creates navigation display. On the method, it doesn't care whether it's a text navigation or image navigation. The factory decided which concrete class to instantiate, and interface guarantees that the display method exists. Here's the abstract factory interface in full. It has the three methods. There's three return types. Each of the return is a abstract product interface, and this is the entire contract. We import three of the product interfaces at the top, not those concrete implementations. If you read this file, you know everything the client needs about the factory. Here's the text theme implementation. It implements the display theme generator. Typescript will reinforce all the three factory methods are present. Each method creates and returns a concrete product for the text family, passing the appropriate DOM element reference. When you swap this for the image theme in the client, the same three DOM elements get handed to a completely different set of concrete product classes. The client code won't change at all. Here's the client code in the TypeScript index file. Both factories are instantiated up front with the same DOM elements. There's a flag, text on or image on, which tracks which theme is active. When the user clicks plus navigation, we call the set navigation method, which calls the create navigation display on whatever factory is active. Same pattern for the window and content. The key insight is the functional body is identical whether we're in text mode or image mode. The factory abstracts away all the concreteness. Here we have the abstract factory pattern demo. These are the two concrete implementations of the abstract factory, and this is the concrete implementation of the abstract products that these factories will generate. So this is dependent on the theme. If we do a text theme, we can generate a navigation, a window, and a content. This is what we have here. If we have the image theme, we can generate the navigation, window, and content here, which is the image. And we can switch these up. So we can have a text, image, the big window, and then create the text content here. We have this abstract factory that is generating abstract products, and that's the overarching way that we can generate these components that we have here, which is the navigation, window, and content. And here we have both the display navigation, display window, and display content. We separate it because we have very specific components that we want to generate. And through this factory, we're expecting that this will generate those abstract products. And they all have the display method that needs to be implemented. Going back here, we have the concrete factory, and each of these implement that create window, create navigation, create content, but they have their own specific concrete components or concrete products that they're generated. So we have the text navigation, we have the image navigation, image window, text window. Each of these concrete implementations also implement that display. And display is just changing the DOM element, the color. It's changing, making it a text instead of an image. We have these buttons that are set to the buttons of the product, window, and content, which has a flag that generates whether or not we want to create that component. It's not technically conditional that we're talking about in our slides. It's more along the lines of a way that we could switch this theme. It doesn't necessarily have to be this way. We could have technically set it in the very beginning. However, we did it this way because we want to change between the themes of the image, the text, and then the content. Here we want to also consider, or just pay attention to the fact that they all have the display method. Regardless of whatever the concrete implementation is on the abstract product, they all will display. So between both of those concrete factories, whatever they generate, it will be able to be generated by either one. And not the specific concrete implementation, but both of these are expected to generate the same type of product. And whatever it generates, it will have to generate a window that has a display. It'll have to generate a content that has display. The abstract factory pattern, we want to use it in just like we had the example where we want to have multiple product families and we want to enforce that the products from the same family are used together. This is a way we can have some compatibility guardrail in the way that it basically explicitly shows that you can't mix families because the factory doesn't expose the cross-family constructors. The second thing is when you want to depend on product interfaces, not the implementation. Your client becomes more portable and testable. You can inject a mock factory and test. And the third is when you want a single point of change to swap the entire family. If you do one factory reference swap, the entire application can change, just like we had in that demo. We don't want to use it by default. If you only have one product family or if mixing products across families is fine, then the abstract factory will add complexity with no benefit. We want to use the factory method instead. It's a lot simpler. The biggest significant trade-off is extensibility in one dimension. If you need to add a new product type, let's say there's like a footer component, you have to update the display theme generator interface. And every single concrete factory, with two factories, that's not too bad. If you have more like 20, it's going to be a really painful refactor. So the pattern is closed to new product types, but it's open to new families. We need to kind of watch out for over-engineering. If your families have only one product, you don't need an abstract factory. You could just use the factory method pattern instead. We have 3 real-world analogies to help solidify this concept. The first one is thinking about furnished collections. IKEA sells coordinated bedroom collections. When you buy from the Hemnes range, it has a bed, dresser, and nightstand, and they all match together. They're products of the same factory. You can mix in pieces from different collections, but they might kind of look wrong. The abstract factory is the range concept. It's guaranteed of internal consistency. The second is we have car trim levels. A sports trim on a BMW has coordinated parts. It has sport seats, sport suspension, sport steering wheel, sport exhaust. And the luxury trim has a completely different but equally coordinated components. The trim level is the concrete factory and its parts are the products. The third one is also thinking about the operating system UI themes. If you switch your operating system to dark mode, everything changes at once. The window chrome, buttons, menus, scroll bars, displayed system dialog. That's the factory swap it's driving the whole coordinated product family. Comparing between relative patterns, the true patterns that can be confused with the abstract factory is the factory method. The factory method creates a single product and lets a subclass decide which concrete class to instantiate. The abstract factory, here it creates a family of products. The factory method is one-dimensional. The abstract factory is two-dimensional. It has the products and it has the families. We have also the builder method. That's about object creation, but is focused on step-by-step construction of a single complex object. You chain calls like set color, set size, build. The abstract factory hands you an already constructed product from a coordinated family in just one shot. If you're thinking about one thing, you might want to use either the factory method or builder. But if you're thinking about having a coordinated set of things, you want to use the abstract factory instead. In summary, the abstract factory pattern encapsulates a coordinated product family behind a single factory interface. It lets you swap the entire family with a single reference change. There's no client code modification needed. There is a trade-off. Adding a new product type will require updating every single factory implementation. It's one of the patterns where the structure looks more complex than the idea. Once you see the two-axis thinking, the product types on one axis, the product families on the other, it becomes more intuitive very quickly. Again, thank you for watching this video. If you want to get more deeper, then definitely recommend the original Gang of Four book. It's a very good reference. For related patterns, check out the factory method and the builder. They're both creational, and they both complement the abstract factory in different ways. If you want to run this demo yourself, you can clone the repo, or you can go to the website in description to have a real world or play around with the code base and the demo itself. If you liked this video, if you can drop a like and subscribe for more patterns in the series, thank you, and I'll see you again next time.